morning, good day. My name is Julian Podgórski. I'm a PhD student of the Institute of Geophysics of Polish Academy of Sciences, and today I'm going to tell you a little bit about maps. The maps, and the cartography in more general. My main occupation is glaciers and satellite images. Those of you who have been with us with EDU-ARCTIC in the last year might remember me. But I have also studied some cartography in the past during my master's studies, so I can tell you some about those things as well. Let's start with a short introduction. It may look quite dry and may resemble things you have already seen in your classes. So what is a map? How do we define a map? What's the formal definition of a map? It's the map. A map is a graphical image of the Earth or its part of the Earth, or actually any other celestial body nowadays. So we can have a map of Mars as well. That is done on a surface, on a flat surface, such as a piece of paper or a screen of a computer, in a scale, so that it's smaller than the real thing, the real world, and with geographic projection. We will talk a little bit about this one later, and with use of graphical symbols. So a map, there are three things that are necessary for something to fit the definition of map. That's a scale, so everything is smaller and we know how much smaller it is and we can control it. The geographic projection, so a mathematical way of converting the sphere to surface. And third, the graphical symbols. That's all the different signs and lines and colors that tell us what does the map represent. And starting with this definition, I'm going to ask some difficult and maybe inconvenient questions to this definition. For example, the very first question that might even have shown up in your brains, in your minds, when looking through a school atlas, it's why do maps have different shapes? When we go through an atlas, we have maps that some of them are rectangular, some of them are more oval, some of them are circular. This strange grid, the graticule, that it can have different shapes, different proportions. And that may seem weird given that our planet Earth always looks the same. There's only a single planet Earth. It doesn't change, but the maps are so very different. And this is because of the projections. Projections are mathematical devices, actually, so they are purely abstract theoretical things that convert the image that we have on the surface of a sphere, so all the land that's on the surface of the globe Earth, into a flat representation on the paper. But if you ever tried to peel an orange and make the peel flat, the skin flat, you see that it's not really possible. It's really hard to do it so that it looks fine. So people have invented very many different mathematical ways of depicting this surface of the sphere on the surface of a flat paper. And the consequence is that there is always some kind of imperfection on a flat map. So there is always a feature of land, of terrain, that is distorted on a map. And depending on what kind of thing we need to be perfectly okay, we choose different projections. For example, we might want that all the surface areas of every continent is proportional correctly to each other, but we don't care about their actual shape. So that may look strange, but their surface area is correct. Or maybe we can want to go the other way around, and we don't care if the continents are too big or too small, but we want them to keep correct shape. And in those two cases, we will be choosing two different projections. And in history, since the idea of projections and coordinate grid was invented, people have made a great many of projections suiting very different purposes. And I will now show you a very interesting thing, and Google Maps is for later. That's a website, jasondavis.com, with the maps and transition. And here you can choose a different projections and look how do they change. So we are starting from Eckert 1. It's a quite typical projection. And let's move to the equirectangular plate carré. It keeps the angles between parallels and meridians right, and they are at right angles. That's correct geographically, but other things might get distorted. And not only we can compare different projections to each other here, we can also look how do they look if we move it a bit. So now this looks quite conventional, but now let's make the world look strange and just pull it down. If we center our map on the North Pole, and from the point of view of map projection, it's only a matter of a little bit different values in the mathematical formula. So it's nothing strange, it's not complicated. It can be just done. The whole map looks weird, looks strange. But we could want to use this map if we only looked at the Arctic. If we crop out the center, then it looks very nice and it looks very reasonable, even though Africa is completely distorted. Another one is cylindrical equal area. It's fairly upside down. It's fairly similar, but this one says equal area. That means that surface area is correct. And to achieve that, we probably know that Europe is smaller than Africa. So to achieve the equal area, that the Europe on map is smaller than Africa to the same proportion as in the real world, we have to change the shape of Russia and Scandinavia and Poland so that it all fits into correct shapes and into right angle graticules. So this is a nice website you can play with at home. It's obviously completely free on the internet. And the next questions, I mentioned that there was a long time since people invented projections. So we might ask, when was the very first map created? What's the oldest map we know? And to answer that question, we actually need archaeology, not cartography, because the maps have been created since the beginning, almost since the beginning of humanity. And the very, very oldest thing that could be called map was found in a cave in Spain. It was dated to 1400 years ago. So it's just quite. It wasn't the same time when the glaciers were dominating in north of Europe, but in the south of Europe, the humans were already there, and they were clever enough to sketch the surrounding landscape like rivers and mountains on a piece of stone. It wasn't a proper map as we know it today, but it was a representation of space. It probably did not have scale, it did not have projection, and it did have graphical symbols. It wasn't map according to definition, but we can say it was a map since it was a representation of the surface of the Earth. But I couldn't find a picture of this archaeological artifact, so I found something a little bit later. So 8,200 years ago, so 6,000 years before current era, in the very first city on Earth, the Çatalhöyük in Turkey, archaeologists found that there was a plan of this town sketched on a clay wall. It's not absolutely certain that it is a map of the town, but there are clues that indicate that we had rectangles that represented rooms in houses, and there is a mountain sketched in the background. You can see it if you look closely on the left side of this rectangular image. There's a triangle, which the archaeologists assume served as an orientation point, so that the small squares and rectangles were supposed to represent the city as seen from a place from which you can also see the volcano. So if you went to the proper hill and oriented it with a volcano, then the map started making sense to you compared to the real thing. And it was actually quite clever. It has a lot of features of the map, though since we don't know the exact shape of the city, it's hard to tell if it's an exact representation and how much does it, how well does it compare to the real town. And the first map that's actually a map was made 4,500 years ago, so 2,500 years before current era. It was made by Babylonian civilization, and what we know of it is a piece of a clay tablet with a plan of an area in a town that's carved into it. And if you look at it, it really does resemble a current map. You can see a road indicated by a double line. You can see different rectangles that represent houses, and they have quite realistic shapes, so to say, if we compare it to what we know about buildings nowadays. And inside those rectangles, there are some spiky shapes, and those spiky shapes are the cuneiform script of the Babylonians. So that means that not only did they draw their surroundings, they also managed to write whose house it is, or what kind, or if it's a temple or fountain or whatever. And the shape of it and the realism of the shapes of the plots and the course of the road indicates that the Babylonians have actually used surveying techniques to do this map. They knew how to measure space, they knew how to convert it to scale, and they knew that how to make maps, more or less. The techniques that have been used to make these maps are not very different from what have been used quite not long ago to make maps as well. So this might be called, in my opinion, one of the first proper maps that fit the definition, but as you saw, there's a lot of things that were earlier. So that's the first kind of town plan, and the first map of the world was also made in Babylonian civilization. That's the image to the left. It doesn't resemble the real world because it's not a proper world map. It's more a symbolic representation of what the Babylonians believe the world looks like. And it was a circle that's surrounded by the bitter river, and the bitter river being the ocean, that's salty. And the lands of the world like Babylonia or Egypt or I don't know if they knew India, but all the areas just simply placed inside the circle in a pattern that it was more religious or traditional than actually geographic. Nevertheless, it's a representation of the world, and it's the first of its kind. It first known of its kind. We can assume that this one was dated for 2,600 years ago, but probably some of them were made earlier, but we just don't know them. And the world map as we actually know it is that first world map that actually was an attempt at drawing the lands as they look in the real world was made in ancient Rome by the Eratosthenes. He was a geographer in Rome. I think he was of Greek origin, and he was the one that thought he knew that the Earth is a globe, is a sphere, and he knew that you can represent the coordinates by means of a grid. So he invented, so to say, the parallels and meridians that were surrounding the Earth, and suggested they can be used to draw a map. He suggested that every single place on the planet will have its own unique pair of parallels and meridians. And here on the right, you can see the map. It was actually created in the 19th century, but it's a reconstruction of what Eratosthenes could draw. Eratosthenes could draw if if he wanted to draw a map using his ideas and his knowledge of the Earth. And obviously, we don't see America here. We don't see Japan. We don't see China, because the Roman people did not know about those places. They didn't know they exist. But the Mediterranean area is depicted quite correctly. The Britain is located in the place it's supposed to be. So in the places where the Roman civilization had their places and they knew those places, the map could be actually drawn quite accurately with use of only Roman kind of technology and cartographic geographic knowledge. Click. But is every map really a map? In the historical part, I mentioned about the prehistorical maps of cave people and Babylonian that were probably not a maps, even though they represented the surface of the Earth. And it's not like every map we see nowadays fit the definition of map. The map is, as we said, a representation of the surface of the Earth. But sometimes there are pictures or images or things that on the first sight we knew it's a map, even though it wouldn't fit the definition. On the left-hand side, you can see this colorful map of Europe, although it's not properly a map. It's an infographic that shows some kind of population forecast. It doesn't really matter what those numbers mean. What I want to say is that the borders are very, very simplified. They're very geometric. They're straight lines with very nice, gentle angles. They're very abstracted shapes of countries that do not represent the reality at all. Nevertheless, we can see the outline of Europe here. We would say it is a map. It represents the countries, the surface of the Earth. They just do it in a very simplified way. There is also no scale stated. There's no projection. There's just lines that fit our perception of Europe. So according to definition, this thing is not a map. But does it really matter? I don't think so. We see that this infographic looks like a map. Everyone would say it's a map. So this definition, even though it's quite strict, that might be a little bit too narrow for our needs. And another thing is, and this map is actually quite modern. It comes from, I think, like last year or 2016. And to the right, we have another case of thing that's representing the surface of the Earth, but it's not a map, and it's even more not a map, since if we look at those black wooden items, they don't resemble maps. They're not flat. They don't have colors. They don't have graticule. They don't have the contours of lands and oceans. They're just pieces of wood that are carved. But the carvings do have a meaning. If you look at this diagram, you can see in the middle, this piece of wood in the middle, that each of those incisions and protrusions of wood represent bays and peninsulas along the Greenland's coast. So the Inuit people figured out that they can take a piece of wood and carve the shape of the coastline into it, and this way use it at sea to compare what they see with this carving. In this way, it serves as a map. It has its graphical symbols, we could say. Since the carved part is a graphical symbol for bay, the not carved part is a graphical symbol for peninsula. But all the other features of map are lost. Nevertheless, we could probably refer to it as it's a map of Greenland coast. It represents the surface of the Earth, the shape of the coastline. We could use it for navigation, just like we use proper sea maps. so there's no reason not to call it a map if it fulfills the same function, is it? And going into more modern things and more ambiguous ones, are digital maps always maps? If we have a Google Earth, if you open the Google Earth program, you can see that the planet is represented as a globe, a sphere, and it's correct. It's good that they do it, because then you're sure everything, all the representations are correct. But it's a globe. It doesn't the mathematics that's used to build this 3D object is not using projection. It doesn't have to, because it can build a virtual 3D object that will have all the shapes and angles and everything correct without projections. There is a little bit of cheating probably when we look at it on the flat screen, but other than that, I don't see a reason for it to use projection. It also doesn't have a graphical symbols and any graphical symbols since it's a satellite image. It's a photograph. A photograph doesn't use graphical symbols to depict the reality. It's just the reality as we see it through a camera. So there's already two features of map that are gone. There is a scale, since this planet is much smaller than the actual Earth, although probably if we were computer 3D programists, we could argue that we can create a digital globe that's the same size as the actual globe and just zoom in or out. So again, we can create a map that doesn't have any feature of a map. It just exists as a digital model of the Earth. And is it still a map? Probably it is. We're using it as a map. We can zoom in to our house. We can see different places. We can use it again for navigation. If we zoom in, it probably starts having scale. Who knows? Maybe they used the programs, the mathematics that force projection if we are zoomed in. So it's quite hard to tell if this thing is a map. It is. I mean, we use it as a map. It's a map. It represents Earth, but it doesn't fit the definition. So it's again quite ambiguous, but again, I'm rather inclined to say it is a map. The thing that probably is not a map, and I would probably argue it is not a map actually, are levels and play areas in video games. We're used to saying that there is a map in, I don't know, Counter-Strike or whatever kind of computer game with levels, but there are different maps there. But actually, they are not maps, they're playing levels. The only thing that could be called a map in a computer game is this little mini-map at the bottom that tells you where your character is located, where are the other characters, where are the rivers in this playing level. Then it is a kind of map since it represents the playing field, the play area, playing level, with use of, in a kind of scale, with use of graphical symbols like red dots for friendly or enemy soldiers, I don't know. But the very thing itself is rather not a map. It's a play area. It doesn't have any single feature of a map. And it even isn't used as a map. It's used as a representation of the real world. It's like when you play Counter-Strike, we're running around something that looks like the real world, and it doesn't look like a map. Good. So moving on to things that are even more not like maps, yet still maps. Metro maps and metro plans. Why are they good and nice, even though they are not maps again? The metro map as we know it, like the scheme of colorful lines with circles and squares indicating stations, were invented in London in 1933. You can see the original thing here on the left. That's how it looked. And at the time, it was quite a revolutionary idea. It's a plan of metro lines that is completely untrue to reality. The stations are not placed in the places that they should be in the true world. They are instead placed on a kind of scheme, a kind of abstract shapes and abstract lines that only show which station is first, which is the last, on which station do the lines intersect, but without thinking about the angle at which they intersect, without thinking about how far away do you have to walk from one line to another. It doesn't matter. The only thing that matters is that lines are crossing in the single space, so we are drawing this space in two colors. At the time, as I said, it was quite revolutionary, but it stuck for the very simple reason. It is a plan or a map that only gives us the information we need. When we travel underground, we don't need the information how far exactly in meters are the two stations from each another. We don't care if the stations are curving, if the line is curving or if it's going on a straight line. We only care that which station is first, which station is last, how many stations do we have to pass before we have to leave the train. And that's why those maps were nice. They simplify the world in a way that is useful and convenient to us. As an example of this simplification, how far it can go, you can look at the map of Warsaw. This gray blob is Warsaw. The blue line and red line are two metro lines, and below is the metro scheme of Warsaw. And you can see that even though in reality the two lines are perpendicular to each other, they form a kind of cross. On the metro scheme, they are parallel. And that's because it's a more convenient and easier way to show them for travelers who don't mind that they do not form a cross on the scheme. It doesn't matter. The only thing that matters is that we can count how many stations do we have to travel. And since we know why the map that it's not a map good, let's now look at a map that is a map. Why is it bad? You know the Google Maps, the ones you go on the internet. When you type Google Maps and you're landing there, I will show you them this to you now. The Google Corporation has chosen a Mercator projection for its online map. The Mercator projection was created in the 16th century by a German Gerhard Mercator, and his purpose, like all the different projections, as I said, they have their purpose, and purpose of this one was sailing the oceans. When sailing the oceans, the captains have to plot course, so the line along which the ship will travel, and Gerhard Mercator created a map that on which the course, that straight line in reality, would be straight line on a map. This made traveling and plotting the course and reaching places much easier for sailors, but there is a big consequence, a big side effect to it, and that is that areas that are far away in the north and far away in the south are much bigger than they should be in reality. Let's look at this map. On it, if you see the Google map here, Greenland is just as big as Africa on this map. It looks okay-ish, we're used to it, and that's bad because Greenland is much, much smaller than Africa. Actually, Greenland, I need to look at my notes. Greenland is 14 times smaller than Africa. You could fit 14 Greenlands into Africa, and despite this, on this map, Greenland is as large or even larger as Africa. It's bad. It's not like the map is bad. The map is good, but only good for sailing. It's bad as a general map for just looking up the world, because it plants in our brains the bad perception of the world. We think that Greenland is much bigger than it actually is, or that Africa is much smaller than it actually is, and it distorts our perception of geography, and absolutely unnecessarily. It's not needed. There's nothing wrong in using a different projection than Mercator for Google Maps, and The good thing is that people at the Google Corporation figured that out. They noticed that it's a not good idea. And nowadays you can go to options and switch on the globe mode. And even online um, in your simple Google Maps website, you can use the circular globe just like in Google Earth. And this one has all the sizes correct, and that's what I recommend to you to use when using Google Maps. It makes you think about the word correctly. Okay, so for the last questions, we have seen a lot of different strange maps. They're very nice. And we might wonder, how were they actually made? What do we have to do to create a map, be it a town plan or a metro plan or an ancient Babylonian thingy? Let's start with the real maps, the ones that fit the definition. They have their scale, their projection, and their graphical symbols. In the past, the maps were created by means of surveying in the field. There were people going out in the field with telescopes, with measuring sticks, and with tables and pencils and rulers, and they were simply drawing what they measured. They were measuring distances to, for example, distance between a house and the hill. They noted that, they drew that in scale, put a little square in a place of house in the correct distance from their hill on which they stood. It was a very tedious, very labor-intensive enterprise, but nevertheless it was done. There was no other way, so everyone was doing that. All the countries, so many companies were doing those surveys, and even I was taught how to do this during my cartography lessons, so that we know the principles and how does it work. But nowadays we live in the future. We live in the age of high technology, and nowadays the maps are mostly made from aerial, airplane or satellite photos and digital information systems. We can have a Landsat satellite or any other satellite that's taking photograph of the surface of the Earth. Then we take those photographs into the computer and do some mathematics, some image processing, and this way we can get maps which are sometimes even better than the ones done with surveying, without really the need of going out into the field. So in the past, we went to the field to actually measure the land, and nowadays the satellites do the measurements for us. And what we do for map making is just converting all the data that come from space to nice-looking, elegant maps. And how the not real maps are made, and this time there's not much difference between the history and today. The maps that are not actual maps, the representations, the metro plans, the caricatures maybe, were always made by artists and designers. They didn't need the cartographic knowledge of mathematics, of projection and scale. They just took the nice shape of Europe, for example. They could even redraw it by hand from a kind of proper map. And then, like in this image from a 1914 newspaper, they could draw in some humans into it, so that all the countries that we know, because we more or less know the map and the shape of it, and into those shapes some human figures were drawn in, which look like fighting men. And that was supposed to be a metaphor of political situation in this era, just right before the First World War. And this map is not a map. It's a graphic that uses map as its base to convey some other message. It was done by hand in the past, since they didn't have computers, so it was done with ink and paper and crayons and printers. Nowadays, it's again the work of artists and designers, but they use computers much more often, just like for everything. And here on the right, you can see it's actually more of a work of art. It's not a kind of political caricature or plan of whatever. It's more of a work of art that's converting the shapes of the Earth into abstract rectangles and squares, And again, it's a work of art by Michael Thompson. And is it a map? Probably not really. We probably wouldn't use it as a map, but it looks like one. We can more or less figure out that these are the shapes of our continents. And even though it's just an artistic enterprise, not an actual map. Thank you for attention.